Our next speaker, which is Professor Irad Bengal. He is the head of Laboratory of AI Business and Data Analytics at the Tel Aviv University. He already published 4 books in this domain. And he also established and co-founder of a startup company called CB4. And he is very well connected to the academia, of course, and in the high-tech industry. So I would like to invite Professor Irad Bengal to give his talk. We need just a few seconds for putting his slide deck on the screen. Are you ready?
Can talk a bit more?
Yes, I can talk a bit more, no problem. So I will talk about data, you know. For what we are seeing already in these first slides, and we will see it in the rest of the day, that the data, some people in this area will say that data for AI is like blood for human beings. Because without real data, without data flowing in, all our AI stuff has different meaning. And more than that, what about power consumption and power CPU that we need to use AI in new system? This is a very big challenge because today all these systems that you saw previously are cloud-based, require servers. We need also to think about IoT devices with the capability of AI, which enable this at the edge devices. We will talk about that in the rest of the day, and Irad is ready. Please.
Thank you very much, Jacob, and thank you for coming here. It's a pleasure to see so many people. I think that it's the first AI meeting within the cyber community. Okay. You hear me? Okay, so what I want to talk is just a few words about LAMBDA, self-promotion, and then talk about a specific project called Digital Living 2030 with Stanford University that focus on applications that I think are very relevant to cyber. I'm not sure I'll be able to give all of them, but at least 1 or 2 of them, and then summarize. So LAMBDA is a new laboratory of AI, machine learning, business, and data analytics. And basically the idea is to take data from companies, real companies, and work together with both academic and expert in the industry to solve real problem. And I urge anyone that is interested to learn more to talk with me after this session. Now, before I go to the Digital Living 2030, I want to talk a few words about what's going on with the companies that are conceptually thought as innovative at the time. So if you think about the 80s and you look at companies that were very trendy, you see many companies that are totally in the physical world. Yeah? You see car companies, you see energy companies, you see appliances and so on. Then came those companies that opened the gate for the digital world. First, the hardware, so HP, IBM, and so on. And then in the 2000, I will talk about the dot-com bubble. The 2000 came those that opened the software gate to the digital world. So Apple, Microsoft, and so on. And now when you talk about trendy companies, you talk about companies that actually play a role, a significant role, both in the physical and in the digital world at the same time. So Amazon is a great company, not just because it has a search engine, which is, by the way, not the best, but because it is associated with the largest supply chain. And same as Alibaba. And Google, when they moved to autonomous car, they moved to the physical world, they rebrand themselves as Alphabet. And Uber, that is actually, again, totally solving a physical problem by transferring it to a digital representation and then working with the AI on top of that. And even the Israeli companies that were very successful, they are all based on physical problem that is projected to the digital world, solved and then mapped again. So with this in view, we understand that when we move forward, more and more of our presence will be in both worlds. And this is exactly this project with Stanford that tries to cover challenges related to AI mostly, but also optimization and data science around this coexistence. And we try to organize it in three buckets: an environmental bucket with smart cities and IoT, a social bucket of research that are around new type of social networks, and the individual well-being bucket that actually look at how we will live in 10, 13 years from now. Will we live better than now, and what are the challenges that we have to cope with? So this is exactly where I want to start with the first example, and I will start with the infrastructure, environmental case, and I want to talk about mobile robot. So first, it's not a new idea. Of course, you can see that already on the 1970s and 80s, people were attracted by mobile, in this case an electric dog that moves according to a signal. And this is how people envision mobile robot. If you see on the right side, of course, it's not exactly the same way, but this is an old idea. Now, when you talk about using mobile robots in a smart city environment, for example, you can think about a mobile that is searching for something. So we can think about, if I think about application, we can think about, of course, Homeland Security type of robots that are looking for targets. It can be missiles, it can be criminals, it can be many things. You can talk about autonomous cars, you can talk about autonomous ambulances that are looking for the next place where we will find an accident. You can talk about robots that are looking for water or sewage leakage. You can talk about even in-body robots that are looking for damages and anomalies. You can talk about other location-based services, robots that serve food and so on. And with the big data in the smart city, you can take all the inputs, and this is what we do in one of this research, and try to rearrange it in a heat map. So the heat map gives some kind of probability where the actual target should be, any one of those applications. So it can be the target to be the next person that needs a lift, and it can be a criminal, or it can be just a location of a water leakage. And on top of these probabilities, those robots, autonomous robots, are working. And when I think about it, I always think about this Minority Report. I don't know if you remember that movie of Tom Cruise, when this small robot here is looking for a sign and moving around. And what we do is to try and model this complex environment where we have basically a loop where we get huge amount of data that represent the probability where the target should be, and then a sort of an update scheme where you take all the new information that the robot gathered from the different sensor and update this probability. Then you have, if it's a mobile robot, then you have a situation when the target itself can move, and the mobile robot should take into account, and then again probing the environment and beginning a new loop. So all this loop of learning the environment, updating the probabilities, taking into account that the targets can move, and then repeating the process is a complex one, but it's although it's complex, it's very nice to see that you can actually apply very simple rule when you talk about a swarm of mobile robots that can actually very efficiently look around and find areas that are of higher probability. Here there are areas that are colored that represent a probability of having a food. And when you look, our ants are moving around and giving signals to each other with pheromone deploying agents. You can actually see that you can create a very complex structure with very simple agents. And this is also a book that we wrote about search and foraging, and it's nice to see that even in the area of AI, we can learn a lot from animals, how they are moving. And I don't have the movie here, but this is basically the scheme that we designed in this research, how those mobile robots can both look for a target. In this case, the target is here. I'm sorry I don't have the movie right now. And this is actually the probability that each of these three robots, three agents see. And eventually, how all these probabilities, by signaling each other, combine to a single probability or heat map where they can work and find those targets quite efficiently. So this is one example, and of course, needless to say that with the cybersecurity, it's not only about manipulating the robots, it's about manipulating the sensors and the way that you can actually look for targets, and actually taking such an application and securing it, it's a very challenging task. I have one more use case to show, so I'll look at the individual well-being. This is another research, again, with Stanford, where basically we are talking about what is called body area network. So again, we will be surrounded by many sensors, some of them internal, some of them external, and all those sensors will use some interaction interfaces like smartwatches and phones and so on, to move them to some place in the cloud where we'll have some sophisticated AI models that will work on those and enable all the service layer, the remote access for different service layers. Here we are talking about an application where we monitor this patient and we will send him to an emergency room when those sensors diagnose that it's about time to do so. And again, the question here, it's first to learn the deterioration process of many patients and also at the personal level of that patient, but not only. The question is how to work on the trade-off between power and bandwidth consumption and accuracy. Because if you talk about a situation where you have 500 sensors around you, you cannot all the time activate them. It will cost too much energy and too much communication, and you need to know how to do so, and this is exactly the research. The idea is to basically to find an optimal solution between the cost of those sensors and the vision of the world, or in this case of this patient. What is the condition of the patient? And what you see here, just as a manipulation of different states of the patient, the true state is the one that you see in blue, and the most likely states by those sensors are the dashed one. And on the bottom you see how those sensors are being, in this case, the number of sensors that we need to manipulate at every moment, because in many cases what we look for are those transitions between one state to another, and therefore the different transition require different set of sensors at any time. I don't have time for the fake news example. If someone is interested, I can talk about it. I will just say that we published a paper, and 2 weeks later there was this scandal of Cambridge Analytics, and they didn't reveal exactly how they did it, but this was a quote from their CEO saying, we just put information into the bloodstream of the internet and then watch it grow, give it a little push every now and again over time to watch it take shape. And so this stuff filtrate to the online community and expand, but with no branding, so it's unattributable and untractable. So this is exactly the idea that we had in mind. Usually when you talk about social network, people focus on influencers, but in many cases we as people are more influenced by people that are surrounding us that are not necessarily influencers. And if you have visibility to the network, and you can actually manipulate the type of seeding where you put those messages, you can reach, and we reached on real or simulation data of real networks, a convergence rate of 35% higher than conventional approaches that look for influencers in the network or that use centrality measures in the networks. So I will just say that we face a new area where we'll see more and more interaction between physical and digital application. Of course, in this area, AI is in the center because AI needs digital information. This is why deep learning became so popular, taking information from the real world and actually being able to, specifically in signal and image and voice processing, actually taking them back to the digital representation where you can do those applications. And in this new world, there will be much more challenges to the cyber community than the one that we are facing right now. So thank you very much and enjoy.
Thank you very much to Professor Bengal. And